Okay, so this is an interesting question. Looks complicated, but really they're just trying to assess whether you know the difference between weight and mass. And in the left-hand side, you've got a diagram which is a beam balance. And what a beam balance does is it compares two things with each other. On the right-hand side, you've got a spring, which is just measuring the extension when you put different masses on it. So the left-hand side compares two objects. Technically speaking, it's comparing the forces between two objects. And on the right-hand side, what we're going to do is we're going to put something onto a spring and measure how much the spring extends. And the spring extends, of course, because there's a force acting on it, which is the force of gravity in this case. So what they're trying to do then is, in this case, is say, well, what's going to be the same and what's going to be different when you go on the moon? Now, the main difference between the Earth and the moon is, of course, the different gravitational field strength. On the Earth, you've got about 10 newtons for every kilogram, and on the moon, you've got about a sixth of that, something of the order of 1.5 newtons per kilogram. So that means what's going to happen is there's going to be a much lower force of gravity extending the spring. Each kilogram causes much less extension on the moon. But if you measure two objects and how they compare with each other, so you put them in the beam balance, then because there's less gravitational force on each side, the comparison is still the same. So any comparison, even on a moon or Jupiter or any other gravitational field, will always be the same. So the balance beam must be exactly the same. Now the question is then, does the spring extend more or less or the same? And we can see that the answer is B, the spring extends less.